Hello and welcome to the special extended edition of my last video. The thing is, I found an answer to my first question, which could seem reasonable at first sight, but which isn't, of course. And I thought that I might as well debunk it right away. So for those of you who already watched my last video of the 3 questions, you can go straight to the end of my first question, right before my second one, where I have added some aspects flat earthers might bring up. Here are the 3 questions I would like to pose to flat earthers. First, the sunset. Why is it that the angle of the setting sun is not always the same? On the Arctic Circle, it goes like this. The sun sets at an angle of 23.5 degrees. In Vancouver, the sun sets at an angle of 41 degrees. At the Tropic of Cancer, the sun sets like this. 66.5 degrees. And on the equator, it goes like this. It's a right angle from up to down, right under the horizon. And if you move further south, it suddenly goes like this. Tropic of Capricorn and Arctic Circle. So, if you watch the sunset and you measure the angle, you always get the result. The angle equals to 90 degrees minus phi, with phi as the parallel you stand on. It's always the same. Please explain this on a flat Earth. Not to mention that on your flat Earth model, the sun should get smaller while moving away from you. The sun never gets smaller while setting. And before you ask how I know this, I've been near the Arctic Circle in Iceland. I've been to the equator and I've seen it with my own eyes. Now there actually is one answer you might come up with. Some of you may say it's due to the different distance. Like this. You have the equator, and when you are at the Arctic Circle or near the Arctic Circle at Iceland, the sun will seem farther away than if you are in Vancouver or near the Tropic of Cancer. Okay, but there's one thing you are forgetting about. The sun is not always above the same parallel. We have the equator, as in the last picture, but the sun is only above the equator in March and September. In June, it's over the Tropic of Cancer. In December, it's above the Tropic of Capricorn. So if in your model the distance between the observer and the sun has an effect on the angle when the sun sets, then this angle should change over the year, since in your model the distance of the sun changes. Again, we are in Iceland. This would be the distance of the sun when it's above the equator. This would be the distance when it's above the Tropic of Cancer. This would be the distance when it's above the Tropic of Capricorn. So if the distance has an effect on the angle should change over the year, which isn't the case. In reality, it goes like this. Here's the Arctic Circle, you know this image. This is March. This is in April. This is in February. It's always the same angle throughout the year. Same thing for Vancouver. Tropic of Cancer. Equator. Since we are looking west, south is on your left and north is on your right. The sun moves from a bit more to the south to a bit more to the north, but the angle never changes. Second question, the stars of the southern hemisphere. Here's your model of the flat Earth. Now, if you are in South America, South Africa, or New Zealand, whenever you look south, you will see the constellation of the Southern Cross, no matter where you are. So where on Earth is the Southern Cross in your model? Third question. Just look at the photo and explain it. This is not a fake. I've seen this myself. I live in Germany and I've been to the North Sea. Before you answer, there are two responses I already know, so don't waste time on them. First, this is all perspective. No, it isn't. On a plane, this would happen. If the top of an object is higher than your eyes, it will seem lower the farther it gets. Okay, on this one I agree with you, and this is the case actually for the wind wheels. But the foot of an object will always seem higher the farther it gets. Here's the proof. This is a plane. I move objects away from me. The foot will always seem higher the farther it goes away. So the explanation is debunked. Second answer, the wind wheels should lean backwards if we were on a globe. Yes, you're right, they should. But how much should they lean backward? Here's the result. If they are at a distance of 111 kilometers, they should lean backwards by 1 degree. I calculated it using Earth's circumference of roughly 40,000 kilometers. There are 360 degrees for one turnaround, so 1 degree equals 111 kilometers. You must have very sharp eyes if you want to see that some object is leaning backwards by 1 degree. And here's the point. At that distance, you would not see the wind wheels because they would be too far away. So the angle is even smaller than 1 degree. Sorry. So if there is any flat earther who is able to answer one of these questions, please be so kind and write them down in the comments. So long.